Electromagnetic waves are classified according to wavelength or wave frequency associated with it. Electromagnetic spectrum is a frequency band of electromagnetic waves existing in nature. According to the increasing frequency, electromagnetic radiation spectrum is formed by radio waves, infrared radiation, optical radiation, including the ultraviolet region, Röntgen radiation, and gamma radiation. Various regions of electromagnetic spectrum differ in the wave of radiation and reception of waves pertaining to a certain spectrum region. That is why there are no sharp boundaries between various regions of electromagnetic spectrum. Radio waves are electromagnetic waves with length exceeding 0.1 mm, frequency less than 3000 GHz. There are several types of radio waves. Very long waves from 3 kHz to 30 kHz, long waves from 30 kHz to 300 kHz, medium waves from 300 kHz to 3 MHz, short waves from 3 MHz to 30 MHz, meter waves from 30 MHz to 300 MHz, decimeter waves from 300 MHz to 3 GHz, centimeter waves from 3 GHz to 30 GHz, microwaves from 30 GHz to 300 GHz. Waves of all radio frequency bands are widely used in engineering. Decimeter and ultra-short meter waves are used in TV and radio broadcasting within the frequency modulation ultra-short wave band. They ensure a high-quality signal reception within the area of direct wave propagation. Radio waves of meter and kilometer bands are used in radio broadcasting and radio communication at great distances with the use of amplitude modulation, AM. AM can transmit signals at any distance within the Earth limits, although to the detriment of the signal itself. This is possible because of the waves reflecting from the planet's ionosphere. Infrared and optical radiation, including ultraviolet, constitute an optical region of electromagnetic spectrum in a broad meaning of the word. Infrared rays include radiation with wavelength from 1 mm to 8000 atomic diameters, about 800 nanometers. Humans feel rays of this spectrum region on their skin as heat. When you bring your hand closer to a fire or red hot object, then you feel heat coming from them. Thus you perceive infrared radiation as heat. As we have mentioned earlier, length of electromagnetic waves of a visible light range varies from 8000 to 4000 atomic diameters, that is 800–400 nanometers. A human eye is a perfect instrument for registering and analyzing electromagnetic waves of this range. This is conditioned by two reasons. First of all, the waves of a visible light spectrum propagate practically without any obstacles in the atmosphere, which is transparent for them. Secondly, the sun's surface temperature, about 5000 degrees Celsius, has the peak of sun rays energy falling exactly on the spectrum's visible part. Thus our main source of light emits huge amounts of energy exactly in the visible light range, and our surrounding environment is to a considerable extent transparent for this radiation. Ultraviolet rays are electromagnetic radiation with wavelength from several thousand to several atomic diameters, 400 to 10 nanometers. Radiation in this part of the spectrum starts influencing vital functions of living organisms. For example, soft ultraviolet rays in the solar spectrum with wavelength approaching to a visible light range result in tan at moderate amounts and severe burns at excessive amounts. Hard or shortwave ultraviolet is destructive for biological cells. That is why it is used in medicine for sterilizing surgery instruments and medical equipment, as it kills all microorganisms on their surfaces. X-rays are radiation within the wavelength range from several atomic diameters to several hundred atom nucleus diameters. X-rays penetrate through soft tissues of a body. That is why they are widely used in medical diagnostics. Röntgen radiation is constituted by electromagnetic waves with length from 50 nanometers to 10 nanometers. This corresponds to the quantum energy from 20 electron volts to 1 mega electron volt. Gamma rays are the shortest length and most high frequency and high energy rays in the electromagnetic spectrum. They consist of ultra-high energy photons. Gamma radiation is constituted by electromagnetic waves with wavelength less than 10 to 2 nanometers. This corresponds to the quantum energy exceeding 0.1 mega electron volts.